students, this is week number 6, lecture number 1, and we are going to study the second important function for chapter number 2. As you remember, in chapter 2, there are two types of function. Exponential function that we have studied last week. We studied three things in exponential. What is the exponential function? What are the properties of exponential function, and question based on the exponential function with some graphs. Here in this week, two important things we are going to study. This, what is the logarithmic function? This is first, then the properties of logarithmic function, and then based questions on logarithmic function. This is lecture 1. And lecture 2, we will study how to solve questions related to conversion with the exponential function. Clear? Also, we will try to some some graph problem with the logarithmic function. So, what is a logarithmic function? A function f such that r to r is said to be a logarithmic function if fx equals to, it is log x, and here it is written b. This b is named as base. This b is named as base. So if the domain is R and the codomain is R, clear? Then how it is defined? It is defined by if here is x, then here is log x base b. This is through f. Clear? What is the domain and what is the codomain, that we will study later. Okay, so a function f such that r to r is said to be a logarithmic function if fx is equal to log x base b, where b is positive, clear, and not equal to 1. Please remember, b is positive and not equal to 1. This is condition number 1, and the condition number 2 is x always greater than 0. X cannot be 0. Clear? This is very important. X cannot be 0. If x is 0, that is not possible. X cannot be 0. And x will remain always positive. X cannot be negative. That's why I mentioned x greater than 0. This is the condition number 2. Clear? Some of the examples we can take, like two cases we will study. It is log 3 base 2, log 4 base 5, log 10 base 2, log 243 base 11. You can take anything. This is case 1. Case 1 means when b is greater than 1. If b is greater than 1, this is the case. Look, 2, 5, 2, 11. These are greater than 1 value. Now it is log 7, but the base is 1 by 2. Log 23 is 1 by 7. Clear? Look, log 47 base is 0.5. So this value 1 by 2, 1 by 7, 0.5. What is this? This is b is between 0 and 1. So like exponential function, there are two possibilities for b. One is 0 to 1, another is greater than 1. Because b is positive, it cannot be negative. Why? The condition on x, it is x greater than equal to, not equal to 0, greater than 0. That means x will remain positive and x cannot be 0. This is very important condition that you need to remember. Clear? Now on the condition based on B, we will consider two cases, and one is when B is greater than 1. So how graph looks for the log x base B? It is x, y, it is log x base B. If B is greater than 1, clear, this is 1, and if B is between 0 and 1, how the graph looks. So both the conditions we need to study, because in exponential function here the graph was increasing, here the graph was decreasing. Okay, so it is log x base B. So let us see what type of graph. So you will have a graph will start from here and it will move like this. Clear? It will be here and it will move like this. It is 1 0 always. It is 1 0 always. And here, so what type of graph? Number one, if you will see, it is a increasing graph. Increasing graph. Why increasing graph? Because it is going for, like x is increasing, so y also going up. So this is going up. So increasing. And if we have between 0 to 1, so the graph will start from here and the graph will move like this. Clear? This is the same 1 comma 0. Clear? If B is between 0 and 1, then the graph will be like this one. Clear? So between 0 to 1, if B is between 0 to 1, the first property comes, it is decreasing. Decreasing graph. Clear? So this is point number 1. Number 2, I told you what is the domain. What is the domain? Look here. Domain is on x-axis values. Look, there is no graph here. No graph. Graph starts from here, means it is starting here. So the domain is R plus. Domain is R plus for logarithmic function. It is R plus. Clear? Set of positive real numbers. And if you see the range, look, the graph is on negative side, the graph is on positive side. Both sides the graph is available. So the third one is range, and the range of logarithmic function is R. If you want to remember, just remember these are opposite in exponential function. Function range was R while the domain was R plus. Range was R plus, domain was R. Here it is opposite. Clear? And the fourth property is all the graphs of logarithmic function are continuous graphs. There is no break anywhere. So the functions are continuous graph. Continuous graph we have. So you can say these have no break. Clear? So these are the 4 important properties of logarithmic function. This is increasing graph, this is domain is R plus, range is R, and it is continuous. So if B is greater than 1, then the graph is increasing. If B between 0 to 1, the graph is decreasing. This you need to remember. Okay. So now we'll move to the third thing. Third thing is you can say property number 5. Important thing. The value of a logarithm. The value of a logarithm of a number with the same base as the number is always 1. What does this mean? The meaning is log b with base b is always equal to 1. Log of a number with the same base as the number is equal to 1. Clear? For example, log of 2 base 2, 1. Log of 7 base 7 is 1. This question generally used during calculation and also asked in exam. Clear? Log 10 base 10 is always 1. Clear? And the point number 6 is logarithm. Logarithm of 1 with any base is 0. Means logarithm of 1 with b is equal to 0. That is, for example, log of 1 with base 7, 0. Log of 20 with, log of 1 with base 20, it is 0. So log with any base, you choose any base, but of 1 is called the logarithmic, is equal to 0 always. Log of 1. Okay. Now this is log. Okay. Now one important function we are studying here is base e. If you remember, in exponential also I explained you, if base e to the power x, that was a special exponential function. Here if it is base b, then we call it natural logarithm. Natural logarithm. Natural logarithm means if base is equal to e. If base is equal to e, then it is called natural logarithm, and it is denoted by ln x. If ln means natural log. So ln means what? ln means log x base e. If base e is there, base e means what is e? 2.718. Clear? If the value of base is e, clear, log x base e, then it is denoted by ln. And ln is what? ln is natural logarithm. Clear? So log of e base e is always equal to 1, and log of 1 base e always equal to 0. Please remember this. So you can write this ln e, or this is, you can write it ln 1. Clear? So this is the function, and all rest properties will remain same. There is no change in the properties of the natural logarithm, because here the value of b is e, and this is what? Greater than 1, more than 1. So the graph of this function will be like this one. It is 1, 0 here. Clear? And what is this? It is increasing. This is the first thing. It is increasing. Number 2, domain is same, r plus. Number 3, range is r. And the fourth property, what we study, it is continuous graph. So log and natural log, two things we are going to study. In your calculator, if you will see, if you open the calculator, then look here, it is written log. This is this log, log. Clear? And this is written ln. This ln is natural log, and this ln is base 10. If we are talking about log, so it is base 10. If we are talking about ln, it is base e. Two different points are mentioned in your calculator. So you need to open your calculator and check where is log written, where is ln written. This is about the how to calculate the value of log and value of ln through calculator. Okay. Now there are 4 important properties of logarithmic function. Properties of logarithmic function. Properties of logarithmic function. What are the properties of logarithmic function? Okay, let's see. Property number 1. And whatever property I am teaching you, it holds for all bases. You write base 2, you write base 3, you write base 10, you write base e. That means these properties are true for logarithm as well as natural logarithm. So both the cases it is true. Like, what is the first property? First property is log AB. So what is this? Log A plus log B. This is the first property. And on the other hand, if you want to write for the natural log, it is ln A plus ln B. So all the properties of logarithm is true for base, means different bases, and for E base, natural log and simple log. Okay. So property number 1 is logarithm of the product of two numbers is equal to logarithm of first number plus logarithm of second number. Second value is log of A upon B. So it is log of A, division means negative, log of B. This is property number 2. What is property number 3? If something is written in power, A power n, so this n will be shifted, power will be shifted here. So this is n log A. This is property number 3. What is property number 4? Property number 4 is very important because I will show you calculator again. This log is for base 10. We can calculate log base 10. This is for log base E. That means with the help of calculator, we can calculate only two base E and base 10. But if we need base 2, so there is a property number 4, how to change the base of logarithm. How to change the base of logarithm? This is very simple. Log of A base B, it is equal to log of A, here base C, and log of B, here base C. You can write any base. Generally what we do, we take log of A base 10 and this is log of B base 10. So we choose base 10. So log of A base B can be written as log A upon log B. Clear? So first we are going to solve little questions on the property number 4. Then we will solve questions related based on property number 1, 2 and 3. Clear? So the first question we are going to solve. Okay, question number, example number 1. Find the values. Example means find the values. Okay, log 7.2. So what we do? It is log 7.2 means what? It is log 7.2 base 10. If nothing is written, here nothing is written. So it means base 10. Please remember. If nothing is written, it is base 10. So we will write 7.2. Oh, first we need to cancel 7.2 and press log. So it will be 0.8573. 0.8573. And generally after decimal we choose 4 places. Clear? You want to calculate log of 231. So what does this mean? It means log of 231 base 10. It is how much? Log of 231. 231 press log 2.3636. The answer is 2.3636. This is the answer. Similarly, if I want to calculate value of ln 23, what is the meaning of ln 23? ln 23 meaning is log 23 base E. Clear? That means 23 we will type here. Okay. And then we will press ln. The answer is 3.1354. 3.1354. So this is how we calculate the value using base 10, using base E. But if this is example number 1, but if example number 2 is with change base. If I need value of log 7 base 2. Clear? Value of 7 base 2. So if you see it is base E, it is base 10. I cannot calculate base 2. So what I will do? What we need to do? We will use this property. This is the property that we are going to use for this. So how we use it? It is log 7 upon log 2. Log 7, log 2. And what is log 7 here? Log 7 means base 10. Log 2 means base 10. Now put the value. Log 7. 7 log 0.8450. It is 0.8450 upon log 2. Okay, 2 is 3010. 0.3010. Now divide it. Divide it. It is 2.8073. It is 2.8073. So this is how we are calculating the value in case of base change. Okay, let us solve one more question. It is, let me tell you, it is log, say 43, and base we are taking 0.1. We have taken less than b, less than 1, 0.1. So what is the answer? It is log 43 base 10 upon log 0.1 base 10. Clear? So how we are going to do it? Okay, let us check the value of log 43. 43 log 1.6334. 1.6334. This is the value of log 43. Now log 0.1. 0.1 log. It is minus 1. The value is minus 1. Minus 1.000, because 4 decimal place, so we will take 0. And if you will divide it, you will get the answer 1.6334 with negative sign. So look here, if we are taking any value, clear, with base any number greater than 1, the answer is always positive. Answer is positive. But here the base is less than 1, the answer is negative. Clear? These things you need to remember. This is how we calculate the value using calculator for various logarithmic and natural logarithmic functions with different bases. Okay, so now this is one type of problem. Clear? What is second type of problem we may ask you? It is example number 1. Rewrite log AB power 2 upon C using logarithmic rules. Logarithmic rules. What are the logarithmic rules? If you remember, we study 4 rules. This is rule number 1, rule number 2, rule number 3. This is for change of base. Clear? So rule number 1, 2 and 3. So how we are going to do it? So look how we will do it. Is, look, log power 2 upon C, and what it is? Division. Division means log of numerator minus log of denominator. Clear? So first we use division property. Now look here, here is multiplication. So it is log A plus log B power 2 minus log C. Clear? This is property of multiplication. But now power also there. So we will use the property of power, log of A plus. This power will be shifted to starting here. So it will be twice of log B minus log of C. So this is how to rewrite. This is how to rewrite the logarithmic expression using logarithmic rules. Clear? This is not difficult, but you need to remember the three properties. Okay, so this is example number 2. What is example number 2? It is log x power 3y upon z power 4. These two are the examples given in your book. Now we will take little difficult question. So it is what log of numerator x cube 3y minus log of denominator. Now multiply log of x power 3 plus log of y minus log of z power 4. Clear? Now this power here, power will be shifted here. Power will be shifted here. So how it will be? 3 log of x plus log of y minus 4 log of z. So this is the answer. Understand? So this is how to reduce any logarithmic function into expansion form using the logarithmic rules. Okay, let us take some little difficult question, and that I am taking from the exercise. This is example number 3, and the question I am taking is log of x square root y upon z power 4, and okay, let us take this one, no problem. So first is division. It is log x square root y minus log z power 4. Clear? So this is negative because division, because of division. Now multiply log of x plus log of square root y minus log of z power 4. And if you will see, my dear students, that this is square root. Square root, how we can write, is log y power 1 upon 2. Root means, square root means 1 upon 2 minus log z power 4. Now power property, shifting to left, it is log x plus this 1 by 2, this 1 by 2 will be shifted here, 1 by 2 log of y minus this 4, shifting in starting 4 log of z. So this is how we are solving questions. One type of question I will also explain you. This is example 4. It is very simple example, but generally students create a problem in this. If numerator we have 2 function, denominator we have 2 function, then how we are going to do? It is, please look here. First we will write, then minus logarithmic of denominator. What it is? Logarithmic of multiplication. Logarithmic log of A plus log of B. Please kindly put them in bracket. Minus. Here logarithmic of CD. Put them in bracket. Log C plus log D. So we use the property of logarithmic function, that is product means plus. This is. Now there is a negative outside. Now open the bracket. Log A, because plus here, no problem. Log A plus log B. But here is minus. So inside functions will change into minus. What students do generally, they write log C negative. This they write correct. But here they write plus. that is wrong. So you need to remember denominator, if two functions are written, so there will be two negative here. Clear? If three functions are there, so three negative will be written here. Okay? This is one thing. And this is lecture number 1. And another lecture we will study how to convert logarithmic function and their graphs. Clear? Okay. So thank you very much. Masalama.